Hello everyone, welcome to today's deep dive into High-Resolution Fundus image database. If you are curious about eye health and want to learn more about what these incredible images reveal, you are in the right place. So let's get started. This video is not only limited to healthcare professionals or researchers, rather it is for anyone who is planning to start their career as a medical engineering student or are interested in this field to gain knowledge. To begin, let's talk why the automatic assessment of retinal vessels is so important. This process plays a crucial role in diagnosing various eye and systemic diseases. Early public screening is essential for prompt and effective treatment, as these conditions need to be diagnosed early. However, achieving accurate segmentation of retinal blood vessel tree is one of the most challenging tasks in the computer-aided analysis of fundus images. In the past, comparisons of vessel segmentation results were limited to low-resolution retinal image databases. To meet the growing demand for higher quality and resolution in fundus images, the High-Resolution Fundus, in short HRF database was created. Imagine a world where eye diseases are detected early and vision loss is prevented. Sounds incredible, right? So, what exactly is HRF dataset? In short, it is a comprehensive collection of high-resolution fundus images which was created to support the development and evaluation of automated methods for the detection of diabetic retinopathy and other retinal diseases. It was first established a decade ago by a collaborative research group with gold standards consisting of two European institutions, Brno University of Technology and Faculty of Electrical Engineering and Communication, Department of Biomedical Engineering, Czech Republic, along with Pattern Recognition Lab at the University of Friedrich Alexander Erlangen, Nuremberg, Germany. Moving ahead, this is a typical fundus image where we see the interior surface of the eye, including the optical disc, macula, and blood vessels. The optic disc is a bright spot where the optic nerve exits the eye. The macula handles central vision, and the blood vessels supply blood to the retina. This detailed image is vital for diagnosing and monitoring conditions like diabetic retinopathy and glaucoma. It helps medical professionals detect early signs of disease and start timely treatment. Talking of the conditions, first let us look at a healthy eye. The optic disc is a round, slightly oval area that is usually sharp and pink. It is where the optic nerve connects to the retina. Blood vessels can be seen branching out from the optic disc and appear smooth without any abnormalities, and macula is generally darker than the surrounding area and free of any yellow deposits. Now, diabetic retinopathy disrupts this peaceful scene. In these images, you might see those blood vessels starting to look swollen, and there could even be signs of bleeding appearing as red spots. Also, there appears yellowish spots indicating blood vessels are leaking fluid. All these signs point to damage caused by high blood sugar levels. Moving ahead, glaucoma, on the other hand, is associated with increased pressure in the eye. In the fundus image, you might not see dramatic changes to the blood vessels or the macula. Instead, the key would be the optic nerve itself. Look for signs of cupping where the optic disc appears more hollowed out, indicating damage to the optic nerve fibers due to the increased pressure. So far, it was the overview. Now, let's deep dive into the dataset and find out more. This dataset contains a total of 45 high-resolution fundus images with 15 images belonging to each category with resolution of 3504 by 2336 pixels. The key feature of this dataset is that all images come with annotations. Also, the masks determining field of view are provided for particular datasets. This is done to selectively capture or analyze specific areas of an image, enhancing focus on regions of interest while excluding irrelevant parts, which is crucial in medical imaging. Also, the dataset has been very valuable to the community and already been widely used by researchers and clinicians with over 5,000 times downloaded globally. Here is a visual representation of each set differing to the others in the form of image captured manually along with segmented and the masked view. Now, with all the descriptions covered, how do we access this dataset? The entire database can be downloaded from the public website of FAU, which can be accessed by the link I'll provide in the description. Additionally, for all the visualization enthusiasts, you can explore and interact with this dataset on another platform called Dataset Ninja, offering a user-friendly interface and advanced visualization tools. One of the first works done with this dataset was on retinal basal segmentation by improved match filtering. This was done by evaluating this newly established high-resolution fundus image database against most commonly used databases, Drive and STARE, for comparison. The STARE database supports algorithm development for automated retinal disease diagnosis, whereas the Drive database serves as a benchmark for blood vessel segmentation algorithms. Both databases feature expert annotated images. For more details, check the links in the description. Inspired by other authors, the method performance was evaluated in terms of sensitivity, specificity, accuracy, and using receiver operating characteristic curve. The performance evaluation shows that the proposed blood vessel segmentation approach is at least comparable with the recent state-of-the-art methods. It outperforms most of them with an accuracy of almost 95% evaluated on the new database, along with achieving decreased computational complexity. The segmentation results can then be used as a basis for other algorithms to analyze abnormalities of the human eye. Additionally, there are many other research papers where the authors have utilized this dataset in their studies. Here I have illustrated only two. I would highly recommend going through them. The links will be provided in the description. The first paper, Applications of Deep Learning in Fundus Images results, shows impressive performance of deep learning for fundus image and in some cases have achieved better performance than experienced humans, which indeed would provide helpful suggestions for ophthalmologists. This makes it as a promising replacement for traditional computer-aided diagnostic systems. In fact, it has already been approved by the US FDA for practical use. We anticipate more deep learning methods becoming robust diagnostic tools in clinical settings. The second paper, Little WNet, reflects on the need of constructing complex algorithmic methodologies in retinal vessel segmentation. In a quest for squeezing an extra drop of performance on public benchmark datasets and adding certain novelty, recent work on this topic shows a trend to develop overcomplicated pipelines, leading to inflated metrics, which in turn provides a false sensation in the community that the problem is solved. This dataset reveals that this is not the case and that retinal vessel segmentation is indeed an ideal area for experimenting with domain adaptation techniques. I would strongly encourage the viewers to explore these papers for a deeper understanding of the current challenges and innovative solutions being proposed in this field. Well, moving ahead in the future, the authors want to support the evaluation and comparison of segmentation results by expanding the dataset. Therefore, the authors encourage everyone to use this database and send back their results, and as a reference to a publication where the algorithm is described. The collected results and comparison will be available on the web page with given references. One important thing to keep in mind is in order to use the dataset, some rules have to be followed. The dataset provided can be freely used for research purposes and not for any commercial use. This is released under the following license: Creative Commons 4.0 Attribution License. If anyone wants to use the database for their research, please cite the following reference as shown at the top of the page. Additionally, if you incorporate any visualization or tools available on the Dataset Ninja website into your work, please ensure to cite the reference provided below accordingly. Well, that would be everything for the video. Thank you for being patient and listening to it. If you are more interested in the fundus dataset, I strongly recommend reading the paper written by Attila Budai and Jan Ostrilic for a deeper understanding and further insights into the research and its applications. Your feedback and questions are always welcome, so feel free to leave them in the comments. Also, if you like the video, do not forget to click the like button, and for more similar contents, subscribe to our channel Fantastic Datasets and where to find them.